Example, the old tin can that for generations has preserved our foods and other products. Open them up, throw them away. Now, better still, recycle them. About 75 billion cans a year in North America. What would life be without the old tin can? Have we ever stopped to appreciate the importance of this marvelous container? Simcoe plant was built primarily to manufacture food containers. Over the years, production evolved into paint, motor oil, pet food, and sundry other products, packed in cans of all shapes and sizes. We manufactured frozen juice containers from paper and even installed the two-piece line to produce pet food cans. Manufacturing a tin can is a very complex operation. We've asked Gord Pangborn, Manager of Engineering, to take us through a step-by-step analysis of how this is accomplished. In addition, we will see the gallon paint can trim presses in operation. Gord, I've had some people ask about how a can is made. Like this video will be viewed by people who know what how the cans are made, but there will also be people out there who are completely unfamiliar with it. Would you be good enough to take the 401, 411 can there and go through the manufacture for us?
Well, this is the finished can. I'll just go through step by step.
Sure, please.
We would bring sheets of tin plate in from our Hamilton plant, cut to the size that we required to get so many bodies out of the sheet of plate. That would be put in the start of the can line, which is a Dexter feed, and these sheets would be automatically fed into a slitter where the size of the body, the length and the width of it would be cut. This is then fed into a body maker, and again, everything is automatic. Each sheet is taken into the body maker. The notches are cut. That's the first station in there, and the notches are strictly to get an overlap at the seams so you don't have four thicknesses of plate or too much tin plate, so you can't handle it.
When you see them on the bottom.
Yeah. It goes from there into the roll form. Now, the roll form either makes the can plain, or as you see on this one, it will bead the can. You can change your tools to make it one way or the other. From there, it goes on what we call a carrier cylinder, which is just basically wrapping this body around a round cylinder and moving it through stations to the edger station.
The edger station forms what we call hooks on the can.
From there, the can receives flux, so we can solder at that point. Then it goes into the bumping station, and the hooks are bent like that. They're put together, and then they're hammered so they're flat. And that's where you see the line down the can on a soldered can. From there, they went over the solder bath, which is just a 52-inch long roll in a bath of molten solder, forcing solder into that seam to make a seal, and it's a hermetic seal. From there, excess solder is wiped off in the wiping station, and that solder can be reused again. It's just a means of making a more attractive package and saving money on it. From there, you went into through a series of elevators, can turners. There's a lot of little machinery in there, but into the flanger, and you formed a flange, and that is the flange at the top where it is rolled over, the same thing on the bottom. From the flanger, it went into what we called our double seamers. That would assemble the end onto the body of the can.
We didn't make them in
Originally, we made them in Simcoe. We had all our own end making equipment. The company started up a new plant in Hamilton. They called it the Central End, and they made all the ends for Canada. So in the last years, I believe it was around 1960, they started shipping the ends into Simcoe. These ends were applied to the can, a hermetic seal made on the can. The can would then flow up to what we call an automatic air tester. Each can that was made was tested. There was air put in the can, the can sealed. If any air leaked out of the can was automatically rejected.
Would it be retested, Gord?
They would be retested in a water tester, and this was done manually, not automatically. From there, we would send the can down through a series of conveyors, cableway conveyors, runways, gravity drops, into our palletizers in the later stages that we had gone to palletized units. From there, it would go automatically, be palletized with an operator there, go automatically onto a conveyor system that would take the cans, the pallets down. It would divide them to whether they're going to be wrapped with a cardboard shroud, steel strapping or plastic strapping, and then tiered into two high, so the truck driver only had to make one trip to pick up a load for the trucks.
2 pallets in the one load.
Yeah.
Gord, the inside enamel on the can there, that was put on by Hamilton, true?
The inside enamel was put on by Hamilton, but we also had the means of spraying a coat of enamel on the cans after it was made. And that was just for double protection or for cans with hard-to-hold product. Apple juice was a hard-to-hold product.
Gord, you mentioned at the body maker you had a roll form body maker. There also was the other type, wing type body maker. Would you explain the difference between the two?
Well, the roll form, your cans were fed automatically cross into a roll that would curl the can into the size of the body, and that would go on the cylinder. The wing form was an original body maker, and they dated right back to about 1900. They were developed. And the body just traveled along flat through the body maker, stopped at a station, and then 2 big wings, or we called them wings, they were forming molds, came down and clamped the can around the form you wanted it. Now, the advantage with this is you could make square cans, oblong cans, round cans, whatever shape you wanted. These originally designed body makers would do that.
When you started, Gord, were most of the lines wing form?
They were all wing form when I started. And again, I have to go back to a man named Carl Trumper who did a lot of work in going into what we call the closing fingers. And they were developed initially by a man that worked in Hamilton plant, and I can't recall his name. He moved to Simcoe, then he went from Simcoe to Vancouver. Then he left the employee as an employee of the company.
Gord, is there a difference between manufacturing the sanitary 401, 411 and, say, the gallon double tight can there?
The manufacturing is basically the same, except on the gallon double tight, we do have what we call ears on it, that a bail or a handle is applied so you can carry the can.
Well, Gord, when I was in Hamilton and we made that can before it was transferred to Simcoe, we used to punch a hole in the body of the can, and the ear was soldered, put through and soldered on. Now, they changed that method in Simcoe. What did they do now?
Well, we had started out that way. We were soldering the ears on, and it was the can never looked good. There was solder on it. They would rust because of the flux, and they would come off. We would have problems occasionally with the ears pulling off. We went to a machine that the company developed, a clincher, and it's a 4-station die machine that actually picks up the ears automatically and puts them right on the body before it goes into the body maker.
They make a little indentation in the body for the ear to sit in?
There are 2 stations where you make indentations. The ear goes into the indentation, then 2 stations where it is clinched or hammered home at that point to make it a unitized package.
And then we made the double tight rings in the Simcoe operation.
The double tight rings and the plugs for this, the closure part.
And the bales.
The bales, they were made. The double tight rings used 3 presses. The plugs used 2 presses. And that required, we had tool and die makers and very skillful ones. We went out, we shopped around when we were getting into a lot of these innovations. We hired people that had been in aircraft industry, farming industry. We tried to make sure we got one or two German people who had gone through very extensive training as an apprentice. And we used these people to help us develop them, along with a supervisor that came from Hamilton, Bill Hickey, who devoted a lot of his time just to make innovations and to make sure that this can was satisfactory for our customers.
At one time, Gordon, didn't we put the bales on by hand and then we went to an automatic installer on the bales?
And that was an outside development from Sweden. We bought the machinery to come in and do that.